Hello, my name is Jeff Morris. I am a senior software engineer at Couchbase, and today I'm going to talk about Couchbase .NET Core integration. So today we're going to look at asynchronous programming, dependency injection, logging, middleware, link to Couchbase, and connection strings. So first up, asynchronous programming. So the .NET Couchbase SDK 3 is fully asynchronous. This is a little different from the SDK 2. SDK 2 had both a synchronous branch or pipeline and an asynchronous pipeline. The new version is async all the way down. So what does this mean? It means your code should be async all the way down as well. You want to avoid blocking calls. Things like task.wait, task.result, task.getAwait, or .getResult. These are blocking API calls. We want to avoid these. Why do we want to do that? We want to prevent deadlocks, avoid thread exhaustion, improve memory and CPU usage, and simply write simpler code that's easier to debug. Lastly, as a best practice, we want to disable the synchronization context by calling configure.await false. This is not as important in the most latest versions of ASP.NET Core, but on the earlier versions, it's critical. So don't mix async and synchronous code. So here we have a action method that is almost 100% async. So on line 3, we get a bucket for a bucket provider, and then we open a collection, the default collection. And then on line 6, we call collection.getAsync and pass it an ID. Then we call .result. This is blocking right here, and this takes a perfectly good asynchronous method and makes potential for deadlock to occur. So what do? You go async all the way down. So once again, on line 3, we open our bucket. On line 6, we get our collection. Then on line 8 to 9, we call collection.getAsync, passing in the ID, .configureAwait false. This is going to turn that blocking method into a non-blocking method. It'll be fully asynchronous, and it'll allow the thread pool to do the job it's supposed to do. This is a much more performant and efficient way of writing code. Finally, we'll return the view. So new is a synchronous enumeration. This is a feature that's new to C#8 and allows you to iterate over async enumerables. This allows this cool syntax, await for each var item and items. The enumeration happens as the data is received, not after. So what that means is, instead of loading the entire collection, or in this case, a nickel response, into memory, it asynchronously handles each row line by line. This has the effect of reducing CPU, reducing memory usage, and freeing up threads, allowing them to do other things. Support was added to all the HTTP services in the SDK, Couchbase SDK. So query, analytics, search, views, etc. So how do you do asynchronous enumeration? There's a couple of different syntaxes, and the most elegant one is the C#8 syntax. So what we do here is on line 1, we have a statement, select default.all from default, where type is equal to name. We then run the query or execute the query against the server and pass in a parameter for the name parameter, calling configure await false again. And then on line 9, we await the results. So await for each var 0, var O, and result.configure await false. Console, and then we output to standard output. What this does, like I said, is instead of loading the entire results into memory and then iterating over them, it pulls each row and enumerates it independently. This is much more efficient, helps GCs. This is what you want to do for high performant .NET, Couchbase.NET applications. Finally, we dispose. You need to dispose of the results because it frees up the underlying stream that allows you to do this. So we can also use the C#7 syntax for asynchronous enumeration. It's just a little more cluttered. So once again, on line 1, we have our statement, and we execute our statement on line 2. We get the results back. And then we call result.get async enumerator. We then, in a while loop, enumerate over each item in the list, calling move.next, move next async, configure await false, and then output the result to the console. Finally, we dispose of the async enumerator, and we also dispose of the stream, the underlying stream. So there's also the ability to do non-string blocking iteration and using the C#7 syntax with the SDK. We don't suggest this, but you may have a use case where this makes sense. Maybe a very small result set you might get a little performance improvement. In this case, we look at line 9. We call var O and result.toEnumerable and then output the results. So once again, this is going to load the entire result set into memory and then one by one enumerate through it. Topic 2 is dependency injection. So dependency injection is everywhere in .NET Core. ASP.NET Core is built basically as a means of hosting dependency injections container. Services are configured to be available throughout the application in setup and startup.cs. These object lifetimes are then managed by the DI framework. Code that's to be injected is registered in the services startup.configure services method in your startup.cs class. Constructor injection is the most common way of resolving a service to its interface. Couchbase offers special boilerplate code for using the SDK in a .NET Core DI. This is suggested over using the Core DI framework directly that comes with ASP.NET. It handles construction and lifetime management of the SDK services like iBucket and iCluster. These are long-lived objects that use things like sockets. These sockets, when you're done using them in threads, when these sockets and threads are done and you're done using them, you want to release them back to the operating system so they can be used. You can get this at www.nuget.org, packages, couchbase.extensions.dependency injection. So Couchbase dependency injection uses a INAME bucket provider for resolving a bucket to an interface. By default, we support a single bucket, resolving to a single bucket. If you need to resolve multiple buckets, you may have that use case, then you will create derived interfaces from INAME bucket provider and give them a different name. This name will then associate with the bucket. We also allow the iCluster provider to be injected as well, with a few caveats. So Couchbase dependency injection using a single bucket is pretty straightforward. The first thing you do is in your startup.cs class, in the configure services method, on the services collection, you add you call .add Couchbase, and then you pass in the options that you want to associate with that cluster in. Finally, you call services.add Couchbase, name bucket provider, and you pass in a name of the bucket that you want to associate with. This will associate the iname bucket provider here with the default bucket. Now, what happens if you want to inject multiple buckets? Well, it's possible. Once again, we call services.add Couchbase, we add our options, then we add a default bucket, services.add Couchbase, iname bucket provider default. Then on line 14, we call services.add Couchbase bucket, but we pass in our derived iBucket provider, and we associate it with the bucket myBucket. These could be whatever names you want. I'm just using this for example. Now, in your controllers, you need to resolve these dependencies. To do so, you simply add the iBucket provider interface to your parameter list of your constructor, and then assign it to a private field, excuse me. Now, on line 6 in index-async, we're going to use that bucket. So what we do is call await bucket provider dot bucket async, call the configure await false, once again, avoid deadlocks. And then on line 11, we open up a default collection. On line 13, we actually do our insert, and we await collection.insert async, our key or document ID name, doc1, and then we pass in a document. Calling configure await false, and finally returning. Now, if you want to use method dependency injection and resolve that way, for iname bucket provider, there's really nothing you have to do different. You just add iname bucket provider as a parameter to the method where you want to resolve that dependency. Now, if you want to resolve an iCluster provider at the method level, there is a little change thing that you have to do. You need to use the from services attribute to ensure that the iCluster provider is injected without causing any errors. If you do not do this, then you will most definitely run into an error. So running through this code, on line 1, we have our method name, index async, and then we have from services attribute, and then finally we have our iCluster provider. We then resolve the cluster on line 3, or call get cluster async. You're not really resolving it. You resolve that internally. ASP.NET does that for you. But you get your cluster, you have your statement, and then you execute your statement on line 7, iterating through the response. Finally, you return your view. Dependency injection cleanup. So cluster and bucket objects, while they're long-lived, they do hold things like threads and use sockets. These are things that you want to release back so the operating system can reuse them. To do this, you create a callback on iHost application lifetime in your configure method of startup.cs. To do this, you simply add iHost application lifetime host as the parameter. You then call host.applicationstopped.register, and you provide a lambda. In this case, we do await.applicationservices get required service iCouchbase lifetime service. Close, then call .close async .configure await. iCouchbase lifetime service has the method close async on it, which ties directly into iCluster.dispose. When this is closed, it will dispose of the cluster object and then any underlying buckets that you've opened. You're going to want to do this when the application shuts down, so that's why we used application stopped. Configuring logging. So logging basics. The Couchbase SDK supports any Microsoft extensions.logging.ilogger implementation. Serlog, inlog, log4net, etc. You could roll your own if you would like to. This is pretty cool because it's very flexible. You add logging by initialing the ilogger factory implementation and injecting it into cluster options when constructing the cluster object. with one caveat. So here's a serial log example. So first, we're going to add the following NuGet packages of dependency to your CS project file, CS_proj file. So package reference include equal to serial log.extensions.logging file, version 2.0.0. This is a very cool package. I use this quite a bit. It enables single line logging, so I can configure logging in my application with one line of code. This is very useful for my scenarios. You may have more advanced ones, so you may want to pick up a more flexible serial log package. In Program CS class, I configure logging on the web host builder. I do this on line 3, where I call configure logging and pass in a lambda. And I call within it builder.add file, and then I send a path to a log file. This is a rolling log file by date, and it's going to create the logs directory in my application. I want the log level to be debug, so this will log anything from debug level up. Once I've done this, I now have logging enabled on my application. There's really nothing you need to do. The SDK, when you add it to the SDK, when you go to register your dependency on the SDK, there's a little change here though. So typically you'd call with logging and pass in a logging provider, but because you're in configure services, you cannot resolve the or at least easily resolve the iLogger factory dependency. So what do? Well, you do nothing. It's pretty cool. When services.add Couchbase bucket, my bucket provider is called, internally we will resolve the dependency on the iLogger factory and inject it into the bucket provider and the cluster object itself. So there's really nothing you need to do here. Topic 4 is middleware. So ASP.NET middleware overview. So middleware is software that's assembled into the ASP.NET app pipeline to handle requests and responses. It's sort of a pipe and filters type architecture. It's really useful. There's a whole bunch of different middlewares that come with ASP.NET by default. For example, there's authentication middleware, there's CORS middleware. There's also some that we can integrate with. And the two important ones that we have with that integrate well with Couchbase are session and caching. So these are it's so common to use these middleware with Couchbase that we have a couple of projects that are community-driven projects. They're not officially supported, but they are community-driven projects. We're on GitHub. You can file issues, you can contribute, or you can simply use it by going to NuGet and pat in to this URL on NuGet. So the caching middleware project depends on an I-distributed cache interface, which is not part of .NET Core itself. It's an extension interface. If you're going to use this in your application, you're going to want to in your CS proj do a package reference to couchbase.extensions.caching version 2.0.0 or whatever's latest. Now, you still have to register it into DI. To do that, you go into your configure services method in startup.cs, and the first thing you do is you register your Couchbase service, add Couchbase, you pass in your options. In this case, we have a connection string to localhost and a default username and password. Please don't use this in your real app. Not secure. Finally, on line 11, we call services.distributed Couchbase cache, and we associate it with the bucket that we want to use as our cache. In this case, I'm using the default bucket. Once you've done this, you can now in your application, when you use any caching, you actually be using the distributed Couchbase cache instead of the default in-memory cache that's provided with ASP.NET Core. Now, a similar project is Session Middleware, is the Session Middleware project, and this depends upon the caching project as its data store. It implements iSession interface and is a community-driven project with pull requests accepted. You can find this on GitHub or NuGet. To use, include the NuGet dependency and configure via DI. Package reference couchbase.extensions.session. To use it in your application, you're going to have to register it. It's very similar to registering couchbase.cache. In this case, once again, in our startup.configureServices method, we'll register our Couchbase dependency, add Couchbase, pass in the options, and then we'll add the distributed cache, add distributed cache, associating it with the bucket default, and then we're going to call services.add_Couchbase session. Now, there's one last thing you need to do. In your startup.configure method, you're going to tell ASP.NET to use session store. To do this, you call app.useSession. Once you've done this, now you'll be using session, and instead of using the in-memory session store that comes with default in ASP.NET Core, you'll be storing your session in Couchbase. So why is that cool? Well, imagine that you have a session up and running. A person has a cart, maybe some products in the cart, and all of a sudden you have a server crash. If that happens and you restart the application, that cart, if it was stored in Couchbase session, will be persisted to disk on Couchbase within Couchbase. Then when this session restarts, you'll be able to pull it right back out. Pretty useful. So here's an example of using session state in a controller. So on line 1, we have an index action method, and we're setting a JSON string with the ID the key. We do this by calling await HTTP context.session.setObject, passing in the key, and then the object that we want to store. In this case, it's a JSON string. Of course, calling configure await false, and then returning the view. Now, to read it out of session, on line 11 and 12, we have a privacy method. And on it, we're awaiting context, HTTP context.session.getObject, and then specifying a string as the type that we're gonna pull out of Couchbase. We pass in the key and configure await false. We'll then assign the results of that to view data with the key message, and then return the view. Now on our view, we would simply read or display or do something with the view data with the message key. This is just like using the in-memory store in ASP.NET Core. There really is no difference. It's all in the configuration. So topic 5 is linkify your nickel queries. So Link to Couchbase is a link provider for Couchbase Nickel. It wraps and uses the SDK and is a community project. We're currently working on SDK 3 support, and by the time you see this video, it should be available. Once again, it's a community maintained project, and I want to give a special thanks to Grant Burnett of Center Edge Software for all the hard work that he's done to make this a successful project. Thank you. Now, if you want to use Link to Couchbase, here's a link to the GitHub repo and then the NuGet package. Now, here's an example of using Link to Couchbase in your application. This is assuming that you've resolved the dependency with Link to Couchbase from NuGet. So in line 1, we create a bucket context object, and we pass in a Couchbase bucket as a parameter. Once you've done that, you can then query your data in the bucket just like you would any other link query. So this is like this would be like just like Entity Framework or Link to SQL or anything like that. It's very powerful. You could do simple queries. You could do more complex joins. We support pretty much everything, if not everything, that Nickel provides. Very cool stuff. Very powerful. So finally, we're gonna go over connection strings. So connection strings are an optional way of specifying cluster options. Basically, you can override most of the defaults defining cluster options, most of the parameters. So here's an example of a very simple connection string. You have a scheme Couchbase, a colon, // and then a host name. You can also use an IP, like below it, 127.0.0.1. These will both resolve correctly. If you want to use enable TLS, you can do that by adding an S to the Couchbase scheme, Couchbases, colon, / localhost. So now we will enable TLS on the client. This assumes, of course, you've set up your certificate correctly. On line 8, we have a little more advanced, a little more complex example that has what looks like query string parameters. So each of these parameters after the question mark are going to be assigned to a property on cluster options. So for example, kv_connect_timeout is directly associated with a property called kv connect timeout on the cluster options object. And similarly, kv_timeout will be assigned to cluster options.kv timeout. So connection strings support several different parameters, not all of them, but most of them. Here's the major ones that are supported. Lots of timeouts, enabling TLS. You can do it also instead of just add. If you don't add the S, you can also enable TLS. Set it equal to true, and then set up your cert, and that'll work as well. You can enable disable mutation tokens. You can set your TCP keep alive variables. You can configure polling. There's a lot you can do. Not everything though. There are some properties of cluster options that do not work with connection strings, and these are more complex objects, things like transcoders and serializers. These simply don't translate to a string. So here's an example of using a connection string in your application. This is kind of a hybrid approach where we're using both an options and a connection string. So first on line 1, we create a custom cluster options and we pass in our credentials, administrator and password. We then create a connection string, and this is going to point to localhost, and we're going to set our kv connect timeout to 10 seconds and our kv timeout to 2.5 seconds. We're then on line 8 going to await connect async and get our cluster by passing in the connection string and the options. Note that there are several overloads for cluster.connect_async. Some of them do not require you to pass in cluster options. You can just pass in administrator and password and then your connection string. So you have some flexibility there. With that, I want to thank you and have a nice day.